So 9.4 is called parametric equations. This is one of those sections that's completely brand new. Like nobody has done parametric equations. And then we get into polar coordinates is 9.5 and polar equations 9.6. All of that's like brand new stuff, okay? It's not complicated, it's just different, that's all. So a parametric equations are sets of equations that express a set of quantities as an explicit function of a number of independent variables known as parameters. These equations will introduce a third variable, t, for time. So when it talks about a parameter, it means the variable t, and t represents time. So these will have an x, a y, and a t. Usually, well, the parametric is two equations. It's an x equals and a y equals, and both of them have t somewhere in that equation. Okay, that's how you can identify parametric. We'll go back and forth between parametric and rectangular. Rectangular is what you already know. So rectangular is your typical y equals or x equals, those things without a t, just the x and y. Parametric graphs versus rectangular graphs. So if you look at these two graphs, in general appearance, they look exactly the same. These both are in the shape of a parabola. Okay, they both have arrows on the end. The only difference on the actual physical picture is these arrows. So parametric has arrows, which means it has direction. So the smallest t would be at the beginning, and then the largest t would be at the end. So as the t increases or as time increases, you get these x and y coordinates, and then you would know to point your arrows in those directions. So at the beginning, we're literally just going to do t charts. You're going to plug in for t. It's just you're plugging in twice because there's two equations. Yeah. Rectangulars are normal. They could be lines. They could be parabolas. It could be a square root. They're just rectangular, which means that it's just x and y, or f of x, because that's the same thing as y, something like that. Yeah. Say again? No. No, not here. All right, so continuous functions, meaning these will never start and stop. They can start and stop at the beginning and the end, but not in between there, okay? There's no holes in these graphs. They can be drawn, without lifting your pencil or your stylus from your screen. The points are plotted in order of increasing value of t. Arrows indicate the direction or orientation of the curve. So like we said, the arrows will point towards the larger t. They call that direction, or they call it orientation. A plane curve is defined as a continuous function that is used by the ordered pair. Okay, so again, your equations are going to be x equals and y equals. Whatever's where that f of t is will actually be values. And the t is called the parameter. So every time we're referred to parameter, because one of the parts of today is eliminating the parameter, it means get rid of t. All right, so what we will do is literally set up a t-chart. So it'll say create a t-chart with 3 variable columns, 1 for t, 1 for x, and 1 for y, and then we add on the actual combination of the coordinate point x, y. Obviously, it's not required, but like when you're doing homework, you don't need that last column. On your quiz, I will give you that box. You will get the column for t, the column for x, the column for y, and then the x, y, and it will give you specific values for t. So if it doesn't give you specific values, we do from like -2 to +2. We plug those values in. If it gives you specific values, then you will put those values in wherever t is, and then you just put them in. So it looks something like this. Sketch the curve given by the parametric equations. X equals t squared minus 4 and y equals t over 2. Given -2 is less than or equal to t, which is less than or equal to 3. So now those are the values that I want to plug in for t. I want to start at -2, go to -1, go to 0, go to 1, go to 2, go to 3. Again, sometimes they give you those, sometimes they don't. If they don't give it, do -2 to +2. That's like your standard. If they do give it, obviously, you have to do those exact ones. Quiz, test, I will give you those like specific ones so you know exactly what to plug in. All right, so then you're going to plug them in. I'm going to plug each of those values into x. So x equals -2 squared minus 4, which is 4 minus 4, or 0. X equals -1 squared minus 4, which is 1 minus 4, or -3. X equals 0 squared minus 4, which is -4. X equals 1 squared minus 4, which is -3. X equals 2 squared minus 4, which is 0. and x equals 3 squared minus 4, 9 minus 4, which is 5. Then I repeat the process for y. So y equals t over 2, negative 2 over 2, which is negative 1. Y equals negative 1 over 2, which stays negative 1/2. Y equals 0 over 2, which is 0. Y equals 1 over 2, stays 1/2. Y equals 2 over 2, which is 1. And y equals 3 over 2, which stays as 3 over 2, or 1 and 1/2, because you're going to have to graph it. You might as well make it the mixed number. So then that last column, we just paired the x with the y. So this is 0, negative 1, negative 3, negative 1/2, negative 4, 0, negative 3, 1/2, 0, 1, and 5, and 1 and 1/2. Now, the lazy people hate that last step, but I will tell you that people make silly mistakes by grabbing the wrong coordinates here. Sometimes they pair the t with the x or the t with the y. So that is why I add that last column. Okay, it should help you now plot these points. So I'm going to plot 0, negative 1. I'm going to plot negative 3 and negative 1/2. Negative 4, 0. Negative 3, positive 1/2. 0, 1, and 5, and 1 and 1/2. And then I connect those points. Should be continuous. And you have to add the arrows on. So the arrows go away from the smallest t. Since this was my first point, they're going to point away from there and towards the largest t, which is that last coordinate point, the 5 and 1 and 1/2. There is no rule on how many arrows. I would say at least 2 to give you a good amount of direction, but you could put more than 2. It doesn't matter. This should be a super easy question. People forget the arrows and people grab the wrong coordinate, so be careful there. Questions on that one?
Like how much easier it is to draw the line.
Yeah. All right. You're going to learn how to graph on your graphing utility. So if you have your handheld with you, you want to get it out. So the first thing is that this is a completely new mode. So we have switched between radians degrees, right? But we have not actually changed the mode of our calculator from function to anything else. So when you click mode on your, like if it's the TI-84 or TI-83, when you click mode, the third or the fourth thing down in the line, it says, mine actually has the full words, function, parametric, polar, SEQ. Or it could just say FUNC, PAR, POL, and SEQ. This is how you tell it to go from your regular function into into parametric. When you do that, it's going to give you the variable of t. So you want to go to that fourth line, and instead of function, you want to highlight parametric. Polar is there. That POL is polar, which that's the next section. So just keep in mind that that's where that is too, because we're going to go back to it. So now when I hit y equals on my graphing utility, you should see it look a little different. When you hit y equals, it no longer just gives you one y equal. For each individual graph, it gives you an x equals and a y equals, because parametric has both of those, right? It's got an x equals and a y equals. And we won't do it yet on the, like I'll type this one in, but if you did 5t, 5, the variable button that says x, comma, t, comma, theta, comma, n, if you hit that, instead of it giving you x like it used to, it's going to give you the t. So it automatically knows to do that with the with the parametric. Go to the next one, and it would be 10 minus 16t squared. And if you hit enter, your graph looks like this. Actually, my window. Would be this. So it would look like that, okay? So we're going to learn to manipulate that a little bit, but for starters right now, you just want to make sure that you have switched it to parametric so that it gives you the two equations on your y equals, and then it gives you the t as your variable.
Where are you
When you switch it to parametric, it's automatically the t when you hit the xt theta button. I'll get to that in a second. It's your regular variable button. So to the right of alpha, it should say x comma t comma theta. You see that? Yeah. This one says sketch the curve by the parametric equations given x equals and y equals. So that we're first going to do it by plugging in my points. So I'm going to start at -1. Now this time I go to 1.5. So you're going to have to go in increments at some point of a fraction. You can go -1, 0, 1, and 1.5. You don't have to go equally spaced the whole time. And you don't have to fill that box. So I'm just starting at -1. I'm going to 1 and 1/2, which is the 3/2. So 3/2. And we're going to plug them in. So again, I'm going to plug into the x. So x equals 4, -1 squared minus 4, which is 4 times 1 minus 4, which is 0. X equals 4, 0 squared minus 4, which is 0 minus 4, -4. X equals 4 times 1 squared minus 4, 4 minus 4, which is 0 again. X equals 4, 3/2, I would keep it as instead of the 1 and 1/2, minus 4. 3/2 squared, here, let me do it down here. 4, 9/4 minus 4, and I get 9 minus 4, which is 5. Then I'm going to repeat that whole process with the y equals. So y equals t, there's no plugging in. It's literally what t is. Y would equal -1, 0, 1, and then 1 and 1/2, or 3/2. My x-y combination would be 0, -1, -4, 0, 0, 1, and 5, and 1 and 1/2. The arrows point towards the last coordinate point. So away from the first one we got towards the last one we got. Questions so far? Okay, so now we're going to graph it on the graphing utility so you can see the difference. So I'm going to take and plug in the same, let me go this way so we can compare them. I'm going to take and plug in those formulas. So I'm going to go back to my y equals. I'm going to clear out what's there. The very first one was 4t squared minus 4. And then the y equals is t. And I hit graph. Yeah.
What should I have the window as? Because it keeps saying error.
So I'm going to fix it right now.
Okay.
Yeah. Mm-hmm. So it's probably your window. We're going to look at it right now. Yep. All right, so right now I have a parabola that's totally turned sideways. It is not cut off the way that my current graph is cut off, right? If you're just like checking your answer, then as long as you know that it's not going to give you that full thing, that's okay. It also doesn't have arrows, so think about that, right? The graph that we hand drew was actually more accurate. If I want to see exactly what it would look like, if I go to window, so if you click on window, and I do my T-min and my T-max to what they gave me here as my T-min and T-max, now it can match exactly. So I'm going to change my T-min to -1. And I'm going to change my T-max to 3/2 or 1 and 1/2. And then I'm going to hit graph again. And then it should match exactly what you got. The arrows are still missing from this. So our graph is still more, our hand-drawn graph is still more accurate. But you can compare it that way. Questions on that one? All right, second thing, so really there's 3 different types of questions in this section. First is graphing using your T-chart. Second is called eliminating the parameter. What did we say the parameter was? T. So at the end of this, the whole goal of this is to eliminate T. It will then look like an equation that you're comfortable, and so maybe you graph it by that, okay? Sometimes you graph it, sometimes you don't have to, but It says many curves are represented by the sets of parametric equations have graphs that can also be represented by rectangular equations with just the x and the y. You're going to solve, so there's two equations, right? One x equals, one y equals, and there's a t in there. You're going to solve one of those equations for t, and then you're going to take what it equals and plug it into the second equation. So we're using substitution. And you're going to eliminate the t. So by doing this, we get one equation at the end and no t. So when you're graphing, you'll lose the orientation. You won't know the arrows because this is going to be an approximation. And the domain on the functions might need to be restricted to graph accurately. So meaning you may not be able to plug in all values for x if there's a square root or if there's a variable in the denominator, that kind of stuff. All right, so here's the question. It just says graph by eliminating the parameter. So the first thing we're going to do is eliminate the parameter. We're going to look at these two equations and figure out which one is easier to solve for t. Y looks like it's easier to solve for t. If I want to get t by itself here, what do I do? Multiply everything by 2. So t would equal 2y. So then I take what t equals and I plug it into the x equals equation. So you have to use the other one. X equals 2y squared minus 4. X equals 4y squared minus 4. What kind of equation is this? It's a parabola. What variable is squared? Y. So this is facing either right or left, right? I have to isolate the y before I can figure out completely. So I take out the 4. Actually, I have to move the 4 first. I'm going to move the 4 first. I would add this 4. And then divide everything by 4 or multiply by a 4th. So it is a y squared equals 1/4 x plus 4. Where is your vertex? Negative 4, 0. Is it pointing to the right or to the left? To the right, because it's a positive 4p. You don't need to give me directrix and focus. Just that is enough. This is an approximation. Now, if you graphed it on your graphing utility to check, it should be pretty close, okay? There's no restriction on the parameter, so it should be your full parabola. The only thing that has to be 100% accurate is the vertex and the direction. Yeah, so because we haven't restricted the t, it would continue on for forever, so you would need those arrows. Yep.
I have a question.
Yeah,
Okay, never mind.
sure. Okay. All right, example 4, graph by eliminating the parameter. So again, we're eliminating the parameter. This time the equations are a little bit more complicated, okay? And honestly, neither of them are that easy to get t by itself. On the left-hand side, like kind of plan ahead. On the left-hand side, I'd have to multiply by the denominator, square both sides to get rid of a square root. That's one option. On the right-hand side, I don't have a square root, but you have 2 t's. So one way or the other, it's kind of a pain, to be honest. So pick a side. Solve the y for t. Yeah? Okay, so we're going to multiply by t plus 1 on both sides. On the left, you distribute. So yt plus y equals, these cancel, t. And then you have 2 t's. So you've got to group your 2 t's. I'm going to move the t's to one side and move the y to the other. So I get yt minus t equals negative y. And then I want to take out a t. I get y minus 1 equals negative y. And then I want to isolate the t, so I divide both sides by y minus 1. Now that whole thing has to get plugged in to t. God bless you. So it's x equals 1 over, God bless you, the square root of negative y over y minus 1 plus 1. What can I do here? I can multiply by the denominator or square both sides and then get rid of it. How you do, the order you do that doesn't really matter. But if I were to square both sides, I'd get x squared, I'm just going to show you what, God bless you, over, now the square of the square root of negative y over y minus 1 plus 1 becomes just negative y over y minus 1 plus 1. So the 1 became squared, which you don't see because it's just 1 squared. The bottom, the square of that square root, gets rid of the square root, okay? No, you're just eliminating the square root. All right, now I want to get, the whole point would be to solve for one of these, and because it's an x squared and a y, I know I can either get it solved for y, because when you've done x squared, you've actually graphed both types of parabolas. One if it's a y on the side by itself, or if it's an x squared on the side by itself. So you could do either one, but you can't leave the fraction in the bottom. So I have to change this to y minus 1 over y minus 1. And I get 1 over negative y plus y cancels out. Negative 1 over y minus 1. And then keep change flip. Y minus 1 over negative 1. So x squared equals, this would be negative 1 times y times negative 1, or negative y plus 1. So then they both have the same denominator. So I did negative y plus y minus 1 all over y minus 1. And the negative y and the positive y canceled out. So again, with a parabola, you know two ways to graph it. You can either get it into y equals form, or sorry, with a parabola that's x squared, or you can get it into standard form we just used in the last chapter. So one way would be move the y over here, move the x to the other side. It would be y equals negative x squared plus 1. You can graph that. Or you can make it x squared equals negative y minus 1. So this would be from our quadratic chapter, like early on in the year, and the transformations, and this is what we just finished. Either way, it's an x squared, which means it opens up or down. It's a negative 4p or a negative x squared, which means it opens downward. And my vertex is at 0, 1. I would say this is the hardest look of anything you're going to see, just because of the complication of having to solve it. Questions on that one? All right, so then the third thing, and the last thing, in parametric is if you are given you'll be given two equations. One is going to be parametric, will have a t in it, and one will not. And your job is to make it so that it does. So the goal, we're working backwards. The goal of this is to end up with two equations, one x equals, one y equals, with t in both of them. So you're going to get given an equation with an eliminated variable and then two additional variables, including t. You're going to substitute the equation with the t into the other equation, the rectangular one. And your solution will be one x equals and one y equals, and they both will have a t in them somewhere. So you're going to start with two equations, one rectangular and one parametric, and the goal is to get them to be both parametric. So they'll look like this. It says find a set of parametric equations to represent the graph of y equals 1 minus x squared using the parameters a, t equals x, and b, t equals 1 minus x. These are two different questions. So it looks like it's one thing with two options, but these are two different questions. They both have the same set of instructions, which is you have y equals 1 minus x squared, and then whatever parameters there. So for a, it's x equals t, and for b, it's t equals 1 minus x. And the goal is to, again, get it to be an x equals and a y equals at the end where they both have t. So one of the equations will already have t. For A, it's which one? X equals t. That's the one that's already done. So I want to solve it for the variable that it has, but it's done. That's one. Then I need to take what it equals and plug it into the initial equation that is not parametric, the rectangular one. So because x equals t, I'm literally going to replace the x squared with a t. And that's the other equation. That's it. For b, you're using the same two equations, so y equals 1 minus x squared, and then t equals 1 minus x. We have to solve the one that has the t for the other variable. So if you look at b, it's the x again. I have to solve it for x. So negative x would equal t minus 1, and then multiply or divide everything by negative 1. X equals negative t plus 1. Or 1 minus t. That doesn't matter. But that's the x equals. Now I take what x equals and I plug it into the rectangular equation in the place of x. So I get y equals 1 minus negative t plus 1 squared. And now we expand and FOIL. So I get y equals 1 minus negative t plus 1 times negative t plus 1. FOIL this out, so negative t times negative t is t squared. Negative t times positive 1 is negative t. Negative t times positive 1 is negative t, and 1 plus 1 is 1. So I end up with 1 minus t squared minus 2t plus 1. And then I got to distribute the sign. 1 minus t squared plus 2t minus 1. Positive 1 and negative 1 cancel out, and I end up with y equals negative t squared plus 2t. Because you expand and FOILed this, right? So it was negative t minus t, which is negative 2t, and then you distributed the negative that was on the front of it. So again, the goal here is to get an x equals and a y equals, and they both have to have t. So one of them will be given to you with the t, and one of them will not. You got to plug that one in. What first one, like A? Because it's just a single variable. We did, yeah, we did square it. It's just you don't have to expand and FOIL it.
I did the same thing, but I did it in 1 minus t.
It should still end up with the same, because it should be t, then you get, so if you did 1 minus t, it's 1 minus t squared, right? 1 minus t times 1 minus t. 1 minus, this is 1 minus t plus t squared. 1 minus 2t plus t squared. And you still distribute that to the negative. 1 minus 1 plus 2t. Yeah. So same answer. The order is different, but same answer. Questions? All right, so tomorrow you'll be able to work on your assignment. So when you, remember I'm not here because of Grab Ash. You're going to do the warm-up. So 9.4 warm-up is first. This is tomorrow. You're going to, I left a video to check the answers on that. And then you're going to submit that as a classwork assignment. And then you'll get to work on the 9.4 homework in class tomorrow after you're done. Questions? Yeah. No, tomorrow's regular day. Yeah.